Thanks Dan, thanks Mark again for the introduction. So what we're going to do now, as mentioned, we're going to unbox the GEN24, the primer GEN24. As you can see here, you can see the logo, it's still manufactured in Austria, right? So just with a knife, we'll open the box, right? There you go. And when you open the box, you can see also that we have all the instruction of how the inverter has been packed, but also how to remove everything from the box. So to put that back on the table, the first things that comes out of this particular box is basically some installation guide and some quick guide. So as you know, the inverter sits on the water when we ship it here to Australia. So the inverters have quite some old software on it. So what you will need to do is run an update so that you can have a better experience when you're commissioning the inverter. So I will just put this on the side. From there, what you need to do is just pull the polystyrene out like this. Yeah, put it on the side. And the first thing that comes out of the box is the wall bracket. So that's how it looks like, right? And you can see that there are some designated holes, right? So what you need to make sure is you use those holes, don't drill through the plate, okay? From there, I have a stand next to me, so I will just hook that up here. So for you guys, what you will need to do is drill or put some screws in where you have those anchor points, all right? From there, we just need to remove the inverter. So here you can see there's a feature to lock the inverter, so I will show you how to snap the inverter in on this wall bracket, okay? So here from the inverter, so I will just move on the side here, right? So you just need to take the inverter out. I'll just put it on the side there. You have some handles next to it. Take the inverter. As you can see, there's a feature here. Just make sure that you hook it up on the wall bracket. All right, we have everything in place. And then I just need to slightly put it inside. And those two features on the side will just lock the inverter in place. As you can see, the inverter can't get out of this wall bracket. All right, so here you can see the new heat sink that comes with the inverter also. So we have a new cooling technology, so it's a more efficient cooling system that we have. Also we have a bigger fan, so we can suck all the air in and blow it on the sides. And with this combination of a bigger fan and bigger fin for the fan and the heat sink technology, we have a better efficiency in terms of cooling, and we don't need to run this fan at 100% also. So that's one of the good advantages of having a bigger fan and this technology there. All right, so here you have all your connection area, which I will show you in a few minutes, but we're just going to assemble the whole unit first so that you can see how it looks like. So the last piece that comes out of the box is basically the actual cover for the inverter. So this is how it looks like. So you just come in, pull that up on the top, and then from there, just with a, it's just here, T20 screwdriver, you just come here, you have a 180-degree lock screw, but you can just put in place with the inverter, all right? So you will see here the lock, yeah, there you go. And then you do the same on the second one, yeah, just lock that in. All right, as you can see, the inverter is back on the wall bracket there. So we have the cover on. So the last step that you will need to do is turn the DC isolator on. So you just switch that on. This isolator, of course, is compliant. So you don't need any external DC isolator with it. So before we go ahead and turn the inverter on, what we will need to do is look at the connection area. So I will take off this particular cover and show you guys all the connections. So let's do this. So again, 180-degree screw lock, pretty easy to remove it. Take this out, put it in the box. Then you see all the connection area. You will see that you have 5 screws. Again, it's 180-degree screw lock, which is easy to remove. All right, so I remove all of those 5s. And then from there, you will see all the connection areas of the inverter, all right? So I will just put the cover on the side. So here you can see your AC connection and then all your DC connection there, all right? One specific feature I mentioned before is the PV point. So this is a dedicated output here, which gets only powered when the grid goes down, right? And this one, you can do it with or without a battery. Maximum power that you can get out of this output is 3 kilowatts. So what you can actually do is just wire this to an external, to a GPU, for example. So it gives you a lot of flexibility and function also. So right hand side is basically AC. Left hand side is your PV. So here you can see that you have two PV input for your MPPT number 1, and you have 2 input for your MPPT number 2, and also you will see that you have your battery connection there. All right. What is really unique in terms of those connection points is you can pull them out. So if you don't want to, let's say, wire the whole inverter here, you can just pull one of those connections out like this. Yeah, there's just like a clamp at the back, and from there, this is how it looks like. What you will need to do is use the spring release clamp there. So you just pull them up and input your wiring. From there, it's pretty simple. Close them, so make sure it's nice and tight. And we often get this question, can you get a shock from there? So there's no way that your fingers fit into any hole there, right? So if this is properly terminated, you should be all fine. Also, you will see on this particular connection point is you can have your multimeter, let's say, input there, right? You can just connect them and do your measurement if required. So you can have it connected and doing your measurement just like this here. So pretty straightforward, I would say. Another special, let's say, feature with the inverter is how you bring your cables to the inverter. So of course, you can run all your cables at the bottom if you want, right? That's possible, but you can also do the side entry if you want. And something which is very special to, let's say, the Australian market, you guys like the inverter to look nice, so you can also do a rear entry both on the DC and AC side. So you will see that there are points at the back where you can just drill and put a gland at the back, all right? So that's really important that you seal it properly. From there, you'll see that we have a new monitoring card. So it's as if we combine the display and the data manager card. So this new card is called the Pilot, all right? And this Pilot has twice the amount of Modbus communication. So in terms of Modbus RTU, it's on this particular plug here. And on this particular plug, you will see that there's M0 and M1. So it's Modbus 0 and Modbus 1. But I will talk a bit about later on. So I can put that back in. Then you have another plug, which is similar to what you have with the Snap inverters with the data manager card. And this is where you do all your IO controls, for example. So you will have your IO1, IO2, and your voltage reference on this particular IO. So this is your digital input and output. All right, so here you have the inverter, the whole connection. One important part is when you put the cover back in, make sure that it is properly screwed in, because that's what makes the inverter IP rated, right? So you need to make sure that you have that pretty nice and tight. So the next step what we're going to go through is basically the commissioning process. So I will show you how to set up this particular inverter. All our Gen24, you just need to have AC connected to it. And from there, you will see some lights blinking at the front. And then we will go through the commissioning process. All right, so now we have the cover and everything back on. We also power the inverter, as mentioned, via an AC cable. So you can see that here it's red light and here also it's a yellow light. What we're gonna do now is commission the inverter and show you how to do it. So how do you activate this Wi-Fi access point of the inverter? You press the button once. There's also a Wps function where you press the button 3 times and then you go to the modem, press the Wps function, and then from there the Wi-Fi syncs. How we're going to show you today is how to commission the inverter via your phone. So what I'm going to do is activate the Wi-Fi access port of the inverter. So just pressing once there, and you will see that it starts blinking. From there, you know that the Wi-Fi access point is available. All right. So let's go now to the phone and show you how to set up the inverter. All right, so what we're gonna do now, we're gonna commission the inverter. So we'll connect the inverter to the customer Wi-Fi, and also we're gonna set some grid settings, which is required as per the Austrian standard. So when you go to site, the first thing that you should do is connect your phone to the customer Wi-Fi, just to make sure you have the right password. So what I'm gonna do here, I'm gonna go to my settings, all right? I will open my Wi-Fi settings. So here you can see I'm connected to Fronius guest, but the one that we're going to use is end customer Wi-Fi. So I select this, enter the password, and make sure that it is connected. So here, this is my hotspot on the second phone. So what we're going to need to make sure is you have the right password. So as you can see, I'm connected. I already did that before, so that's where it just went straight away. All right. So then the next thing is you will open the Solar Start app. All right. So this is the commissioning app that you can use, and you click on Start Installation. Over here, you have 3 different options. You have Gen24 plus Taro, you have Snap Inverter, and others. So if you need to commission the Snap Inverter, you can use this platform. Also, if you have a data manager box, you can use this app. what we're gonna do now is commission the GEN24 or the tower, for example. So here, the first thing that you can do is do an update on the inverter. As you may know, all our stock are sitting on the water for quite a bit of time, meaning that those inverters have quite an old software. And in the meantime, we have new software coming out. So it's always good to run a software update before you start the commissioning. So you can download this firmware basically when you're at home, right? As you can see, it can be a big file. And then from there, you can start the update here, all right? So I will show you later on how to do this step. The inverter that I have here has already been updated. So I will just keep this update process here, all right? So here it says, okay, press the push button on the Wi-Fi access point of the inverter. So just press the button on the inverter and you will see that the blue light on the right hand side will start to blink, all right? So what I'm going to do is I'm going to go to my Wi-Fi settings, okay? And then from there, I will select the inverter. As you can see, the ID of the inverter is now the serial number. So before it was a 240 or 239 number. Now it's Fronius _ the serial number. So here I have the inverter and the password is 1, 2, 3, 4, 5, 6, 7, 8. So we didn't change it. It's still the same as what you do before, right? So here you can see that I'm getting connected to the inverter. All right, from there, what I would do is open the app again and wait to go to the next step. All right, so what we're gonna do first is set up the network of the inverter. So you click on the first tab. You will need to set up a password for the username customer. Please make sure you remember that, it's very important. So here we will put customer 123 as a test one, all right? Customer 123, and then click on save. So it's just loading. So again, remember that you need to write this one down. Try to use the same on all the jobs. It will make your life easier, all right? So the next step, then you need to set up the general information about the system. So just the name. So I will just put chronic as an example here. Or we can just put test 1, 2, 3, for example, all right? And make sure that you have a date and time set up correctly. So here you have March. You can change your location if required, but it's really important that your time and date is right, all right? So I will just press next. Then the next one is the terms and conditions. So of course, if your customer want to read through that, you can take a screenshot. Or if you even want to read this particular part, you can go and have a look. From there, you just click agree and press next, okay? Then from there, you have your network settings. So of course, you can do a hardwired, which is your Ethernet. You can select Wi-Fi. This is what we're gonna do. And also you have another option, which is called access point. So what is this access point? So if your customer doesn't have, let's say, internet on site, what you can do is have this Wi-Fi access point of the inverter always on. So what they can do is they can connect their phone to this Wi-Fi access point and check what the system is doing. So from there, they will be able to see the inverter homepage. It's as if you're seeing all the data from the inverter. It's as if you have the screen on your phone. So this is also an option available. All right, so what we're gonna do now for our inverter, so we're gonna connect that to the customer Wi-Fi. So we're gonna use the Wi-Fi option. So here you can see there's different Wi-Fi available, and you can see the customer Wi-Fi, the one that we checked before, the end customer Wi-Fi. So we can select this one, all right? You can set up, write down the Wi-Fi password. So we check before that we have the right one, okay? So I will just enter the password here and select view so that I'm sure that I enter the right one. You can see the host name also, and the connection is automatic. So if you have any requirement from, let's say, the customer's network where you need to put a static IP address, you can select static and enter all the information. Usually the IT person or the customer will give you all those information about the IP address, subnet mask, DNS, or gateway, all right? So we're not doing a static, we're gonna select automatic. From there, you just need to press connect, all right? From there, what will happen is the inverter will try to connect to the customer network. So here you can see connected, then from there, it's all good, all right? So you can then scroll down and press next. And from there, you will see that the job is done in terms of the network. You also have a second option, of course. We also have a Wps function on the inverter where you can just press the button twice and you will see that the LED on the right hand side will turn green and start blinking. From there, you just need to go to the customer modem, press the WPS button, and it will just sync straight away together. So that's another option if required. All right, so after configuring the network, what you will need to do is set up the product. All right, so here it's for trained technicians, so it's for the installers to set up the grid settings on the inverter. So you select product, you will see that there's a username, so make sure that you have the right password. So here the username is technician and the password is whatever you set. So for us here we had technician 123 with capital letter T. All right, so that's where it's really important, because if you forget this particular password, we'll need to send you quite a long temporary password to reset that. So from there you click on save, and you will go to the next stage where you will need to set up basically some grid parameters of the inverter. Add, let's say, the PV also connected to the inverter. So here you can see that we grabbed some information that you entered before. So you have test 1 to 3, you have Australia, Melbourne, so all of this we had done before. So you just grab everything from the previous entry. From there you have the country setup, so it's very important that you do that so that it's compliant as per the Australian standard and also with the requirement that the DNSP gave you. So here we have Australia, you have all your different code for different states also. All right, so here we use a US VIC for example, and press next. The next part is to add different components. So you'll need to add one. So here, if I click on the plus button there, you have PV generator, power meter, or battery. All right. So let me select PV generator. So you can see your first tracker, PV1, and your second tracker, PV2. If they are both parallel together, connected together, let's say, you can select also PV1 plus PV2 if you want. So I will just turn the PV2 off, and I will just put 1000 watts for the PV1 and click on add. All right. Also, you can add a meter, for example. So here you can see the type of Fronius smart meter is the Fronius smart meter here. All right, so you need to make sure that this is selected. You have also the application, so where the location of the meters. It's really important that you select grid connection point. So this is feeding point, and then from there you click on add. So here, because we don't have anything, we don't have a smart meter connected to it, you can see that it's saying primary meter and it's red there, which means that it is not detected, and also you can't see any value. So that's where you know, okay, maybe we should check the wiring. For this case, we don't have one connected, so we'll just delete it, and from there press next. All right, so then from there you have your IO controls that you can set up here. So here you have your backup power configuration if required, and also your load management there, right? So you can say which you can assign the pins to different load management. So we are not doing it here, this setting, so we press next. All right, and finally you have your export limitation. So here you can select limit the entire system if required. So for example, you need to enter the total DC power of the entire system, so you can put 5000 watts for example. And here the maximum permissible export power, that's where you need to be careful. Here it's selected in percentage. You need to select watt. I would always recommend to use watts, it's easier. Then from there you just put your export limit value. All right, so we're not using it again, so I will just turn it off and press next. From there, your product is basically set up, so all the grid settings and all the different component has been added, and you should be all done, right? So then the last step is just to set up a SolarWeb. So because this inverter has already been added to our portal, it will just automatically go green there. But what will happen is when you click on the solar.web, all right, so what will happen is it will say, okay, make sure that you have internet connection to your phone, all right? So you just need to turn your 3G, turn off your Wi-Fi, and you just go to SolarWeb, log in and add the system, all right? So you have a serial number, you just need to add the system to your portal. So pretty straight forward. So you will see, I will just click on it and it will just turn green for this one. So from there, we are done with the whole setup, all right? So you can just click on finish and it will go to the inverter homepage. All right, so on the inverter homepage, you will see all the, let's say, current power. So this is on the general page, you see the current power of the inverter. So it's doing 0 watts because it's not connected
at the moment on the DC side. So you have the current power and also the total energy that the inverter has been producing. Also, it shows the device state. So again, we don't have any power going to it. So it's saying too low DC power, all right? Then you can click on Advanced. That's where you see real-time value of the inverter or devices that you have connected. So here you can see the total AC output of the inverter, the total DC power from the panels also, and also the voltage and currents. And if you have a battery also, you can see some information there. So this is basically real-time value of the inverter. Okay, so if you click on the three dot at the top there, you have device configuration. So this is basically what we've been through. So you have the components. So if you need to add a battery, you need to add, let's say, a meter. That's where you go to, all right? Then you can go to the function and IO. So again, we went through this particular port. So that's where you set up all your IOS control that you need. Then from there, you can go to the inverter where you have all the inverter information. So you have PV1, PV2, and some ripple controls and over different settings there, all right? So that's all the values that you can basically change or select, okay? So from there, you can go to the energy management. So here you can control different loads. All right, so if you go to load management, you can say, okay, you want to prioritize your battery first, then your home pilot, then after that your load management. Or you can say, okay, I want to prioritize my load management. Usually what people will say is if they have a battery, they say, okay, I have excess of power, send it to my battery first. If it is full, basically send it to the home pilot. And if I still have excess of power, I can do load management with up to 4 different loads that you can control there. So pretty unique feature, all right? So then going back, you also have, let's say, system information. That's where you have a lot of different settings. So the general information about the system, so the name, the time zone, and also the location that you can manually set if required. You can run an update if you want. So that's where, if you want just to drop off, just use a bit like a Dropbox file, right? So you just drop the update there, or you can browse a file on your phone. You just need to make sure that it is in SWU format. So usually when you download it from our website, it's a zip file. So you need to unzip it and put it there. So the next part is the startup wizard if required. So here you can start those 3 processes that we've been through if you want. You can do a factory reset also. You can do all the settings or some everything except the network if you want. You can go to the event log, so it will show all your different error codes also here. So if this is basically a pre-series unit, you can also get some information about the system. So you have the version of the inverter, so all the hardware, basically some different values, let's say software version of the inverter, and also pilot version. So this is some, I would say, some question that maybe tech support will ask you. So to check some settings on the inverter and version on the inverter. You have the network, so just to see if it is connected or disconnected. So this is, let's say, a nice summary that you can have also on the particular platform there. You have a safety and grid regulation. So here you have all your startup reconnection that you can have a look. You can have a look at the values there, all right? And also, let's say you have let's say an inspector coming to site and say, okay, I want to see all your settings. You can just print the PDF and you will have basically all the settings. So here you can see the grid support function where you have all your fault right through, your different settings in terms of voltage, all right, your inner upper limit, and also a few other settings there. So you can see all your grid settings, all your different parameters can be seen here, all right? So from there, you have a license manager and support, so that's nothing that we will go too much in details. Okay, from there you have the communication tab. That's where you can set up your communication there. So Ethernet, Wi-Fi, or access point. So if you need to do it manually, you can do it there. So let's say your customer changed their Wi-Fi password or modem. Yes, you can go to this page, but remember we have a Wps function, which you just press a button on the inverter and press a button on the modem and it will just sync together. Also Modbus settings, that's where you can do all your Modbus settings. So if you have Modbus TCP there. That's where you enter all your different settings. So we're just going to do cancel and go back to the communication tab. You have your safety and grid regulation. So if the country setup, that's where you enter all your grid settings required. So volt, vol mode. You can enter the code there. So I can't show you this one. You can do your export limitation. So we already showed you guys this particular one. You have your IO management. So that's where you have different ways of controlling the inverter via the IO ports if required. And yeah, from there you have also this auto test. All right. Then from there you can go back to the overview where you see all the different settings. So here, as you can see, different, I'm logging as a technician, all right? So if I go to change user, I'm a technician. If I'm a customer, I can see basically less. Of course, I can't change a lot of settings when I'm a customer. So as you can see, there's different level of, let's say, settings there. But that's pretty much it in terms of the monitoring. Definitely encourage you guys to have a play with it and check some of the settings.
So as you can see, that's how we do the commissioning of the inverter, right? Pretty straightforward, pretty basics, I would say. And it's really easy to sync, let's say, the inverter to the customer network, right? So as you can see, we discussed a lot of different features with the inverter, a lot of benefits. As you can see, you will spend less time commissioning the inverter, setting up the inverter now. And from there, it should be pretty simple. So if you have any question, please feel free to ask us after the session. But thanks again for watching the video. Back to you guys.
Okay, just on the export limit settings there, it's Sebastian brought up a good point. There is two options, watts and percentage. When they're selecting, it's always probably easier if the installer selects watts rather than a percentage and try and calculate that out. All right, so I was just going to go through a couple of slides as well for myself, and I'll just bring that up now. Okay, so with the Gen24, as you guys are probably already aware, there's two options now. There's the SIMO Gen24s and the Primos are now coming out. Stock is going to be available to the Primo Gen24s pretty well from now on if you're getting your orders in. And with this single phase, the Primos, the range is 3 to 6 kilowatts. And then on the SIMOs, the 3-phase range, you've got the 6 to 10 kilowatt. There's also a 3 to 5 kilowatt range. Just please note with the 3 to 5 kilowatt range, it's only the PV point backup, not the full backup option. I'll go into that a bit later. So Fronius has paired up with BYD for batteries. Fronius is very happy to have a business relationship with BYD because BYD have such good battery technology. They're using lithium iron phosphate, LiFePO4 lithium ion cells, which is very stable and safe lithium ion technology with a long lifespan. And they developed a product that it's very modular and easy to retrofit more batteries onto later if the customer wants. In this model here, you can see it's the HVS model, which is, I say the S stands for small because you can just stack up to 4 of the modules, which will get you up to about 10 kilowatt hours of storage. And it goes up in 2.6 kilowatt hour steps. And then you've got the HVM model where you can actually stack up to 8 modules high, and that'll get you up to 22 kilowatt hours of storage. Just bear in mind that they are slightly different. The HVS and HVM, they're not interchangeable. The battery types, they are running at slightly different voltages. So with the BYD batteries, you can actually have up to 3 of the stacks if more energy storage is required. All right, so with the Gen24, Fronius has spent quite a few years research and development to develop this new Gen24 product, so it's got very efficient multi-flow technology. What does multi-flow technology mean? It just means that it's able to supply the loads at the same time it's charging the battery or discharging from the battery. So even when the grid goes down, you're still able to charge the battery from the solar and supply the loads in backup mode, because it's using DC coupled technology. So your DC power is going straight through from your solar array to the battery, and because the batteries that are compatible, like the BYD, are a high voltage battery, there's very minimal losses there, which makes the system very efficient. And you're also able to add on a Gen24 to an existing system in an AC coupled style scenario as well. So you can use the AC power out of another inverter to charge the battery that's connected to the Gen24. And if you add more solar to the Gen24 as well, then that's extra power to charge and discharge from the battery. So with this high efficiency style DC high voltage system, it meant that the Gen24 actually came in first place when it was tested by HTW Berlin. The overall efficiency was 94%, and that's the best result that HTW Berlin has ever seen in their inspection that they do. They do testing every year of different hybrid battery systems, and the Gen24 has come out as the highest efficiency system. And this just means you're going to get great yields out of a battery system. And also, like you see some of the other systems there's some AC coupled style systems which aren't as efficient, but even other systems that were DC coupled, the Gen24 system was the most efficient. All right, so another great feature on the Gen24s is PV point. So this is your basic backup power option in the event of a grid failure, and it is only supplied when the grid is out. So it's that second AC output that Sebastian was showing in the inverter. You can wire that straight to a GPO that is RCD protected, and then the customer has some power in the event of a blackout. It's going to, when the grid comes back up and the inverter automatically reconnects, you do lose power at this PV point. So it's only active when the grid is down. You get about up to 3 kilowatts power out of this PV point. And one of the great features of this is you don't even need to have a battery for this to work. If the sun's shining and they've got solar power, you can use PV point without a battery. And it'll supply whatever power is available out of the PV array. And it's just a very easy installation, so it makes it a cost-effective install for some backup power for customers. It will also work in the event of if you do have a battery as well. So if the grid goes down, this just shows how it works. You're getting power straight through from your PV array to PV point when the grid is down. And if the customer has a battery, it will also be able to supply power to PV point. And you can also charge the battery at the same time from the solar. So you got the option there of giving people some basic backup power without even having to add a battery. So there's still the second option for backup power. With the Gen24s, you can go to what we call a full backup option, where you can, with the bigger inverters, say a SIMO 10, you could probably back up the entire house. That obviously depends on the loads in the house, but the SIMO 10 is going to supply true three-phase power and can power three-phase appliances, three-phase motors. It can do that. Obviously, you got to have a look at the surge capacity on your motors and what they're going to draw, but it is true three-phase backup power with a SIMO inverter. There is a switchover time of up to 60 seconds from when the grid goes down before the backup kicks in. It also supplies single-phase load, so it can be unbalanced between the phases as well. And I just got a slide here that just shows what happens when the grid goes down. You will require a separate backup switch box. There are some components you need that aren't supplied by Fronius, which is a contactor and 12-volt relay. to disconnect the Gen24 from the grid. And then once it's disconnected, you're in backup mode and you're able to supply power to the loads and also charge the battery at the same time. All right, so with the Gen24, it's got open interfaces on it, which means you're able to integrate the Gen24 with home automation systems and also EV charging stations. And this is going to maximize the customer's self-consumption if they start getting smart about how they use their PV power during the day, especially if they don't have a battery as yet. So it's got all the standard open interfaces that the Snap inverters had. It's got LAN and Wi-Fi and the Modbus connection for the smart meter. And there's also a second Modbus connection now as well. And it's got the digital inputs and outputs that Sebastian was showing, the digital IOs he was showing in the connection on the video. So that's where you can have load management control for the inverter and perhaps set up a hot water system where you are switching that load on and off, programmed by the Gen24. And with the open interfaces, you're able to communicate through to home automation systems as well. This is just going to give the customer much better self-consumption of their solar system. It's similar to what was on the Snap inverters. They had 4 different digital inputs, outputs. The same again with the Snap from the Snap inverters to the Gen24. You're able to prioritize those loads, do load management. Of course, to make this all happen, you really want the Fronius smart meter with the Gen24. And that'll enable you to do all of this energy flow management in the system and give you that top system monitoring platform that we've got, SolarWeb. It'll give you the extra consumption data as well. And just so you guys are aware who are online, that Fronius has actually got a promotion going at the moment where any purchase of a Gen24 between now and the end of June, the smart meter is given for free with the unit. So that's free smart meter with every Gen24 sold until end of June.
I'm just bored, bloody a dozen. Can we send about 6 back then, mate?
Well, if you've purchased it in March, then yeah, that's perhaps we can have a discussion with the guys here. Was it in February, was it?
Yeah.
Oh, okay. Perhaps we can have a chat to the guys at Fronius about this, and we'll see what we can do there.
Yeah. Hello, Rumi.
Thank you. Hey, boys, you should have waited. We're waiting for that.
Well, wish you had given us the mail on that one, mate.
All right, so just moving along, the Gen24s have very wide MPPT voltage range, so it's going to be very easy to design your PV array with. Designing your strings for your customer's rooftop is going to be very easy because you've got a wide voltage range. You can see you've got down as low as 65 volts and up to 530 volts DC on the MPPT for the primos, and 22 amps on one input and 12 amps on the second input. And then it's same with the SIMOs. In the Gen24s, you've got a very wide voltage range, slightly different voltage range. You've got 80 volts all the way up to 800 volts DC with the SIMOs. And where it says here 150% oversizing, that's approved by Fronius and guaranteed by Fronius that you can have oversize the PV array 50% over the AC rating of the Gen24. Now, obviously, in Australia, we've got the CEC rules around 33% oversizing. However, if you have a battery added to the system, you're not restricted to that 33% oversizing. You can oversize up to 150%. So that means that, yeah, you can have larger PV arrays on the inverters. All right, so one very blatantly obvious feature on the Gen24s is the massive fan on the front. Why have Fronius done this? It's because they take active cooling very seriously, and they think it's very important to extend the lifespan of all the electrical components in the system. As we all know, standard grid connect inverters working hard for 10 to 12 hours a day. And now with a hybrid inverter, you add batteries to it, that inverter could be operating for 20 hours, maybe even 24 hours a day. So you've got extra working hours on the electrical components. So the lifespan of the components needs to be taken into account even more with a battery hybrid inverter. And as we all know, keeping electrical components cool will extend their lifespan. It also gives them better efficiency. The cooler you keep any electrical device, the more efficient it is. That's just a fact of nature. And so active cooling is a very important feature on any power inverters from Fronius's perspective anyway. It's going to reduce your costs as well by having active cooling because it extends the lifespan of the device. And here's a little animation of how the active cooling works on the Gen24. You can see the fan on the front is, because it's much larger, it's going to be spinning at much lower RPMs as well. So it's as it's spinning at a lower speed, it's probably going to be less noisy than a smaller fan. And then you've also see with all the big radial heatsink fins on there, it's very efficient design for actively cooling the components inside the inverter. And another feature that's been in Fronius inverters for many years now, it's been in the Snap inverters for quite a long time, is the Dynamic Peak Manager. What that is just a shadow tolerant algorithm. It's built into the max power point tracker of all Fronius inverters. And this just decreases your losses if you got partial shading. So something that's brought up quite often is people think that as soon as you shade one panel, the whole string is dragged down of panels. Well, that's not really true because you've also got bypass diodes in each panel. And with a good max power point tracker, you can really reduce the losses you get from partial shading. So what it's doing, it's finding what we call the global max power point. This little animation is a good little demonstration of what happens in partial shading and how it finds that global max power point. You can see the dot on the left. The red dot is your global max power point, and some max power point trackers only find the local power point, which is the other dot, but it just means you get overall more power out of the PV array when there's partial shading. And another thing that Fronius prides itself on is good service and having fast service in the event that there is any fault or problem with an inverter. The Gen24 has been designed with this in mind, being able to quickly swap out parts rather than have to exchange the whole inverter and having to disconnect all the wiring and redo all the wiring. You are able to just take out the main power stack and replace it very easily. And then what used to be called the data manager card, now called the pilot card, that's easily removed as well. So we can do quite fast service on the inverters if it is required. And we've still got the great monitoring platform in SolarWeb, so you can see all your data very easily on what the system's doing. And there is extra features coming soon with SolarWeb, or some of them available now on SolarWeb Premium. But here's your home screen from SolarWeb. As you're probably all familiar with, on SolarWeb, you got the bubble chart on the top left showing you your power usage, and if you've got a smart meter, it shows your consumption data as well. And one great feature that I'd encourage all of you to have a look at, if you're in a system, if you've got a customer system that has a smart meter connected to it, check out the simulation tool on SolarWeb. You can see on this screen, what you're doing is actually clicking on Analysis from the home page, and then click on Simulation, and then it'll bring up this screen here, and then you click on Storage. Once you click on Storage, it'll bring you up all the different BYD battery sizing options, and you can just select different batteries, and it tells you what the self-sufficiency rate is going to be if that battery is added to the system, because it's doing calculations in the background based on the customer's consumption, because they've got the smart meter, and also their PV production. And you'll find that as you choose different battery sizes, this self-sufficiency rate changes. And sometimes as you add larger and larger batteries, the self-sufficiency rate doesn't actually improve that much. That's because you've sort of hit the limits of what their PV array can charge the battery at. So you can really customize and get the best size energy storage that the customer would need, which can be a great selling tool in the future. You know, if you've got a customer who's looking at getting energy storage, if they've got the smart meter installed, you can just run them through this and quickly show them which size battery they should get. All right, guys, well, that's the end of the slides there. This slide here is just talking about Fronius's vision of 24 hours of sun. Fronius can't get to 100% renewables by ourselves, so we need to partner with other companies like BYD so that we can get closer to running off 100% renewables. All right, so let's start with the questions, guys. Any questions on this so far?
It's all pretty clear on our end. It looks pretty good.
Maybe I've got one, Daniel, regarding noise. You mentioned it, and that's a common question what we have from customers. Some devices are quite noisy, the fan circulating, and you said this one is much better designed. That's what I understood correctly, right?
Yeah, that's right. The feedback we're getting so far is that the GEN24s, generally the fan is not running at 100% capacity of its RPM, what it can do, because it's got it's a larger fan, so it's running at lower RPM. So straight away it's making less noise already. And because it's got such large amount of radial fins there you've seen in the heatsink, it's very efficient at cooling off the inverter. And so generally the fan's running at very low RPM, which is going to create less noise.
So would you say that would be like half as noisy as the standard inverter?
There is a dB rating on the spec sheet. I believe it's dB noise ratings are a bit of a minefield, like, because it depends on where it's measured from and what the
meter away or whatever.
And as I said, that fan speed is going to vary depending on how hot it is and how hard the inverter's working. So the dB rating, it's a bit tricky to go by, but in general, the feedback we're getting is it's less noisy than the snap inverters when the fans are working hard.
Yeah.
I've got a question. You spoke about the hardware setup for the full backup, where you have to get the additional contactor and the interface relays.
Yeah.
Is there any thoughts from Fronius's point of view? Because the information that we've got, and they're as scarce as chicken's teeth to get hold of. We've had our wholesalers trying to chase these things down now for about 3 weeks, and apparently ABB are only bringing in like a handful at a time, and they're so popular. You're on back orders. I was told yesterday it could be June before I get any. And we've got a BYD system sitting in the warehouse and the GEN24 installed, and the customer wanting to know what's going on. So is there any plans from Fronius's point of view to be able to supply these components that initially are suggested to us are ABB, both the contactor and the interface relay?
Yeah, there are different types of relays and contactors you can use, not just ABB. Perhaps if we get you the there's a quick guide, instruction guide on setting up the backup switching, and that lists all the different types of contactors that you can use in this setup.
Is that out of the hardware setup manual?
I don't know if you'll find the full list in the you've got the full list of different contactors there.
Well, it's showing the option 1, which is the ABB contactor, and then it talks about a finder as well. But when our installer spoke to someone in Fronius, they suggested that the option 1 with the ABB and the interface relay as a finder were the 2 combinations, and not really to vary away from that. I've had the wholesalers trying to find an option as well, and they're just as difficult as well.
Okay, well, from what I've heard, that the other contactors, I'm trying to remember the name of it now, but it is readily available in the market. Perhaps I need to look for, if the ABB one's not readily available, they could look at getting the other contactor. Yeah, the 12-volt relay, I think the finder is the one that's easiest to get hold of. Were they having trouble getting hold of the 12-volt relay as well? Or?
Well, looking at this, it's a 230 volt, 230 to 400 is the range on both the contactor and the interface relay. We weren't looking for the 12 volt. We were looking for the other one. In option 1 was where we were told to, that's what we needed to install.
Okay.
That's straight out of your book. It's page 6 of 13 out of the hardware setup.
The setup for the full backup option.
Yes.
Yeah, I don't have that in front of me, but yeah, there is. From what I remember, there's a few other options there with the 240-volt contactors.
Okay.
Yeah, if that's not on there, I can send you through the setup guide that's got those different contactor options.
That'd be really appreciated.
Yeah. And just on that backup option, quite often get asked, well, why has Fronius gone to a separate backup switching option that's not built into the inverter? There's a couple of reasons for that. Reason number 1 is quite often you might be in the scenario where you're installing an inverter on the shed, as an example, and the customer wants to back up the loads at the house. If you had to run the mains all the way to the shed because the backup option was built into the inverter, that becomes more costly and time consuming having to run the full mains. Whereas having a separate backup box, you're able to install that next to the switchboard at the house, and that way you only need to run a data and control cable back to the shed to the inverter to be able to operate in backup mode. The other reason also is the inverters. What happens if an inverter fails and the backup option is built into the inverter, because you have essential loads connected to this backup switch box, and if that inverter happens to fail and that backup contactor is open, then not only do you have a faulty inverter, you've also got a customer who has no power on their essential loads. So it really raises that call out from a faulty inverter to critical get here straight away, I've got no power. Whereas if it's a separate backup switch box, that's not going to happen even if the inverter fails. But there's some of the reasons why Fronius has gone down the path of having a separate box rather than building that option into the inverter. I mean, and it's great they've also got the other cost-effective option of PV point, where it's just generally a single power point for the customer who just wants a little bit of power in the event of a blackout.
Yeah.
But I'll definitely look into that contactor supply issue you've got there
Right.
and try and help you guys out.
That'd be great. Much appreciated.
All right. Any other questions?
No, we're pretty clear.
Sounds like we covered all. Very good explanation, and yeah, sorry again about the video. And as Daniel said, we make it available, so I will share the link afterwards so you can have another look.
All right.
Thank you.
Yeah, we'll definitely get that link available for you guys.
Yeah.
Thanks for your time, hey?
Thank you so much to
Okay,
everyone
thanks, Bob.
Thanks,
for
guys.
time. Much
Thanks.
appreciated. Contact us if you have any more questions or if you need some stock. We are there for you. We are available. Just let us know. Thanks a lot, guys.